you notice that smoke alarms, fire alarms, and other alarms have very, very specific descriptions in front? That's because their sensors work differently, and this is how specifically a fire alarm works, or the idea behind it. My mic will not be picking up the sound unless I'm speaking, so I apologize for speaking over the beeping. I need to so that the mic can detect the beeping because the frequency is just too high. So when that little light, as you could see at the end of the sensor, is close enough and in the range of the infrared of the candle, it can send a signal back to our Arduino and of course to the buzzer. The premise behind the sensor is basically a photodiode. So if you remember what LEDs are, light emitting diodes, they're the exact opposite. Instead of emitting light, when light hits the diode, they make electron hole pairs in the depletion region, which creates holes in one direction, electrons in the other, and there is current going through your system. This is perfect for detection systems. Now, I did say light, but there's light all around us, so how come it's not going off all the time? Well, it works in a very specific infrared range. You very carefully choose and dope your material accordingly. This specific sensor, I think, is sensitive between 900 and 1100 nanometer range, which is in the infrared range. Hence why we refer to this also sometimes as an infrared sensor. But that is not all about photodiodes. Photodiodes can be used for everything. As you just saw, this is a very, very specific diode for a very, very specific range. You can also use photodiodes sensitive to certain wavelength ranges of light, only if a blue light shines on it. You will get a current and then you can input that into your system as a yes or a no, or it could be analog as well where it can have a range of values. I feel like this is only one of the 1,000 applications of diode manipulation.